Welcome. Today we're diving into two essential concepts in statistics, variance and standard deviation. These terms might sound intimidating at first, but they're actually quite approachable once you understand their purpose. Both variance and standard deviation help us measure how spread out or clustered a set of data is. Imagine you have a group of test scores. Knowing the average is helpful, but understanding how much those scores differ from each other gives you a deeper insight. That's where variance and standard deviation come in. Let's start by exploring why measuring data spread is so important in real-world scenarios. Think about two classrooms. Both have an average test score of 80, but in one class everyone scored between 78 and 82, while in the other scores range from 60 to 100. The averages are the same, but the spread is very different. This spread tells us about consistency and reliability. A smaller spread means students performed similarly, while a larger spread shows more variation. Understanding this difference is crucial in fields like education, business, and science, where consistency can be just as important as the average itself. Variance is a measure that tells us how far each number in a data set is from the mean, and thus from every other number in the set. In simple terms, it's the average of the squared differences from the mean. Squaring the differences ensures that negative and positive deviations don't cancel each other out. This gives us a single number that represents the overall spread of the data. The higher the variance, the more spread out the data points are. Let's see how this works with a simple example. Calculate variance. We start by finding the mean or average of our data set. Suppose we have the numbers 2, 4, 6, 8, and 10. Add them up to get 30, then divide by 5, which gives us a mean of 6. This mean acts as our reference point for measuring how far each value in the set deviates from the center. It's a simple but crucial first step in understanding the spread of our data. Next, we subtract the mean from each number in our data set to find the deviation for each value. For our example, the deviations are -4, -2, 0, 2, and 4. These numbers show how far each value is from the mean, but if we simply added them up, they would cancel each other out. That's why we need the next step, squaring each deviation. Now we square each deviation to eliminate negative numbers and emphasize larger differences. In our example, squaring -4, -2, 0, 2, and 4 gives us 16, 4, 0, 4, and 16. Squaring not only makes all values positive, but it also gives more weight to larger deviations, highlighting outliers in the data. This step is key to accurately measuring the spread. After squaring the deviations, we find the average of these squared numbers. For our data, the squared deviations are 16, 4, 0, 4, and 16. Adding them up gives 40, and dividing by 5 the number of data points results in a variance of 8. This final number 8 tells us the average squared distance from the mean. It's a simple yet powerful way to summarize the spread of our data. It's important to note that there are two types of variance: population variance and sample variance. Population variance is used when you have data for the entire group you're studying, while sample variance is used when you only have a subset. The calculation is almost the same, but for sample variance you divide by 1 less than the number of data points, n1. Instead of n, this small adjustment helps correct for bias when estimating the spread from a sample. You might wonder why we square the deviations instead of just taking their absolute values. Squaring serves two purposes. It ensures all differences are positive, and it gives more weight to larger differences. This means that outliers, values far from the mean, have a bigger impact on the variance. This property is especially useful in fields like finance or quality control, where extreme values can be significant. Standard deviation is closely related to variance, but it's often more intuitive. While variance gives us the average squared deviation, standard deviation brings us back to the original units of the data by taking the square root of the variance. This makes it easier to interpret and compare with the original data values. Let's see how this works in practice. Find the standard deviation. Simply take the square root of the variance. In our earlier example, the variance was 8, so the standard deviation is the square root of 8, which is about 2.83. This number tells us, on average, how far each data point is from the mean, using the same units as the original data. It's a straightforward calculation that adds clarity to your data analysis. Low standard deviation means that most data points are close to the mean, indicating consistency. A high standard deviation suggests that the data points are more spread out, showing greater variability. This makes standard deviation a valuable tool for comparing different data sets or understanding the reliability of your data. It's widely used in fields like finance, science, and quality control. While variance and standard deviation both measure spread, standard deviation is generally preferred for interpretation because it's in the same units as the original data. Variance is useful for calculations and theoretical work, but standard deviation is more practical for everyday analysis. Knowing when to use each can make your data analysis more effective. Let's revisit our test scores example. If one class has a standard deviation of 2 and another has a standard deviation of 10, we can immediately see that the first class's scores are much more consistent. This kind of insight is invaluable for teachers, administrators, and even students who want to understand performance trends. Business, variance, and standard deviation are used to assess risk and performance. For example, a company might analyze the standard deviation of monthly sales to understand how predictable their revenue is. High variability could signal market instability, while low variability suggests steady performance. These metrics help businesses make informed decisions about strategy and resource allocation. Scientists use variance and standard deviation to analyze experimental results. For instance, in medical research, these measures help determine whether a treatment consistently produces similar outcomes. High standard deviation might indicate that the treatment's effects are unpredictable, while low standard deviation suggests reliable results. This information is crucial for drawing valid conclusions from experiment. In finance, standard deviation is a key measure of investment risk. Investors look at the standard deviation of returns to gauge how much an asset's price fluctuates. A stock with a high standard deviation is riskier because its price swings more widely, while a low standard deviation indicates more stable performance. This helps investors balance risk and reward in their portfolios. Visual aids like graphs and charts can make it easier to understand variance and standard deviation. For example, a bell curve shows how data is distributed around the mean. A narrow curve indicates low variance, while a wide curve shows high variance. These visuals help make abstract concepts more concrete and accessible. One common misconception is that a high average always means better performance. However, without considering variance or standard deviation, you might miss important details about consistency. Another mistake is confusing variance with standard deviation. They're related but not the same. Understanding both is key to accurate data analysis. While variance is a powerful tool, it has limitations. Because it squares the differences, it can be heavily influenced by outliers, extreme values that are far from the mean. This can sometimes give a misleading impression of the data's spread. It's important to consider the context and look at other measures when analyzing data. Standard deviation also has its drawbacks. It assumes that data is distributed in a certain way, usually symmetrically around the mean. If your data is skewed or has multiple peaks, standard deviation might not fully capture the spread. Always use it alongside other statistical tools for a complete picture. Besides variance and standard deviation, there are other ways to measure spread, such as range and interquartile range. The range is simply the difference between the highest and lowest values, while the interquartile range focuses on the middle 50% of the data. These measures can provide additional insights, especially when dealing with unusual data sets. Imagine you're comparing temperatures in two cities. Both have an average temperature of 20 degrees C, but one city's temperatures range from 18 degrees C to 22 degrees C, while the other ranges from 10 degrees C to 30 degrees C. The second city has a much higher variance and standard deviation, indicating more unpredictable weather. This kind of analysis is useful for travelers and meteorologists alike. In manufacturing, companies monitor variance and standard deviation to ensure product quality. If the diameter of machine parts varies too much, it could lead to malfunctions. By keeping standard deviation low, manufacturers can maintain consistent quality and reduce the risk of defects. This saves time, money, and reputation. Coaches and analysts use variance and standard deviation to evaluate player performance. A player with a low standard deviation in scoring is more consistent, while a high standard deviation might indicate unpredictability. This information helps teams make strategic decisions about training and game plans. Quality control teams rely on standard deviation to monitor processes. If the standard deviation of a product's weight or size suddenly increases, it could signal a problem in the production line. Early detection allows for quick adjustments, ensuring products meet quality standards and customer expectations. Educators use standard deviation to assess the effectiveness of teaching methods. If a new approach leads to lower standard deviation in test scores, it suggests that students are learning more consistently. This feedback helps teachers refine their methods and improve learning outcomes. Healthcare professionals analyze standard deviation to monitor patient outcomes. For example, if a treatment consistently produces similar results, low standard deviation, it's considered reliable. High standard deviation might prompt further investigation into factors affecting patient responses. Marketers use standard deviation to evaluate campaign performance. If the results of a campaign have a low standard deviation, it means the outcomes are predictable and the strategy is effective. High standard deviation might indicate that the campaign's impact varies widely across different audiences. In social sciences, researchers use standard deviation to understand patterns in survey responses or behavioral studies. A low standard deviation suggests that most people responded similarly, while a high standard deviation indicates diverse opinions or behaviors. This helps researchers draw meaningful conclusions from their studies. Tech companies track standard deviation to monitor system performance. For example, if the response time of a website has a low standard deviation, users can expect consistent performance. High standard deviation might signal technical issues or inconsistent user experiences, prompting further investigation. Logistics companies use standard deviation to track delivery times. A low standard deviation means deliveries are consistently on time, while a high standard deviation suggests unpredictable service. This information helps companies optimize routes and improve customer satisfaction. Customer service teams analyze standard deviation in response times to ensure consistent support. If the standard deviation is low, customers receive timely help. High standard deviation may indicate staffing issues or process bottlenecks that need attention. Project managers use standard deviation to track project timelines and budgets. A low standard deviation in completion times or costs indicates that projects are predictable and well managed. High standard deviation might signal risks or inefficiencies that need to be addressed. Retailers monitor standard deviation in sales data to understand customer buying patterns. Low standard deviation means sales are steady, while high standard deviation could indicate seasonal trends or unpredictable demand. This helps retailers manage inventory and plan promotions effectively. Transportation companies use standard deviation to analyze travel times. Consistent travel times, low standard deviation mean reliable service, while high standard deviation could indicate traffic issues or route inefficiencies. This data helps improve scheduling and customer experience. Energy companies track standard deviation in usage patterns to forecast demand and manage supply. Low standard deviation means predictable energy use, while high standard deviation could signal changing consumer habits or external factors. This helps ensure efficient energy distribution. Farmers and agricultural scientists use standard deviation to monitor crop yields. Low standard deviation means consistent harvests, while high standard deviation might indicate issues with weather, pests, or soil quality. This information guides decisions on planting and resource allocation. Entertainment companies analyze standard deviation in audience ratings or box office sales to gauge the consistency of their content's success. Low standard deviation suggests a formula that works, while high standard deviation might prompt creative changes or new strategies. E-commerce businesses track standard deviation in order volumes and delivery times to optimize operations. Low standard deviation means reliable service, while high standard deviation could indicate supply chain issues or fluctuating demand. This helps companies improve customer satisfaction and efficiency. Communication teams use standard deviation to analyze response rates to messages or campaigns. Low standard deviation means the audience is responding consistently, while high standard deviation could signal mixed engagement. This helps refine messaging strategies for better results. Companies track standard deviation in technology adoption rates to understand how quickly and uniformly new tools are embraced. Low standard deviation suggests smooth adoption, while high standard deviation might indicate resistance or training needs. This insight supports better change management. Environmental scientists use standard deviation to analyze changes in pollution levels, temperatures, or wildlife populations. Low standard deviation indicates stable conditions, while high standard deviation could signal environmental stress or change. This data informs policy and conservation efforts. Sum up, variance and standard deviation are powerful tools for understanding how data is spread out. Variance gives us the average squared distance from the mean, while standard deviation translates that into the original units, making it easier to interpret. Both are widely used across industries to assess consistency, risk, and reliability. By mastering these concepts, you'll be better equipped to analyze and interpret data in any field. Now that you understand variance and standard deviation, you can apply these concepts to real-world problems. Whether you're analyzing test scores, business performance, or scientific data, these measures will help you make more informed decisions. Remember, understanding the spread of your data is just as important as knowing the average. Keep practicing, and soon these statistical tools will become second nature in your analysis toolkit.